This video will go through the conclusions that you should have come up with for the graphing and describing left and right hand behaviors of polynomial functions. On the first page, your graphs should have looked something like these 6 in group A. Some of the windows you did have to adjust in order to get everything fully in your window, but most of them were a nice 10 by 10 standard window except for number 1. The second group, group B, your graphs look something more like these. These windows were a little bit more difficult to adjust in order to get your graphs. But if you see, as you see, I have the X max and X min and the Y max and min labeled at the top and the bottom and left and right of the axes. But those are your 6 graphs for A and then 6 graphs for B. From these different graphs, they actually fell into 2 different categories, which is why they were grouped Group A and Group B. So those 2 groups are either described as odd or even degree. If we look at Group A, you will see that all of them are actually odd degree. And the even degree, they were odd for Group A, sorry. And then the even degrees ended up coming from Group B. Okay, you can determine that by looking at the highest or the largest exponent of each equation. And if I can quickly just scroll back to Group B, you notice that all of the highest degree, the 6, 4, 2, 6, 4, and 4, the highest degree, the exponent of all of them were even numbers, where Group A, all of them happen to be odd numbers. So some similarities of the graphs, how to determine if a function is odd or even. So if we look at Group A, the odd ones, what do you notice? You should have noticed stuff like that the ends were going in opposite directions. The odd functions, the ends are in opposite directions. For Group B, the even functions, you should notice that the ends are going in the same direction on the left and the right. These were even functions, and the ends are in the same direction. When we talk about things going to in the same direction on the left side or the right side, we are also referring to them as either rising to the right or falling to the right. Every time we look at a function, we read our functions just like we read a book from left to right. So functions that rise to the right versus fall to the right, what will affect that? And that happens when, if you look, we're rising to the right. When you had a positive, the lead coefficient is positive. Right, that lead coefficient is A, so we had a positive A. That will rise to the right. It will fall to the right if your lead coefficient was negative. You actually did stuff like this back in when you were learning to graph lines. You're at your positive slope versus your negative slope. Something that went up to the right had a positive slope, or something that went down to the right had a negative slope. This one was positive, this one was negative. So the same idea. You fall to the right, you have a negative lead coefficient. Rise to the right, you have a positive coefficient. Okay, so some of the other conclusions. Number 1 was just some information. that the graph is continuous of all polynomial functions, meaning we don't pick up our pencil or pens or draw them. There's no holes, there's no asymptotes, there's nothing. They are continuous. Number 2, the degree of your polynomial will be odd if the graph starts and stops in opposite directions. Okay, the degree of the polynomial is even if the graph starts and stops in the same direction. So as we talked about group A versus group B. Group A was odd, opposite directions where it started and stopped, and group B was even, where they were going in the same direction. Okay, number 3, the lead coefficient is positive, then the graph summary from before will rise to the right. If the lead coefficient of polynomial is negative, then the graph falls to the right. And that's what we talked about before with positive or negative A. Now, the number of solutions of a polynomial is equal to the degree. Okay, so if you have a degree of 4, if we solve that polynomial, we will get 4 solutions. If your degree is 3, you will end up with 3 solutions. And of course, imaginary solutions always come in pairs, right? We did that with the quadratic formula. We always had plus and minus any of our imaginary answers. Okay, then these are just some general things to make sure you remember. Talk about describing left and right hand behaviors. We have to consider 2 and 3 above, right? Is it odd or even? Does it rise or fall to the right as you have a positive or negative coefficient? So degree and a positive or negative coefficient, very, very, very important. Having an idea of what they look like before we actually graph them can help us see a complete graph in your viewing window. Okay, so describing end behavior. What happens at the ends? This is big, this is new notation. This means as x approaches negative infinity. So this arrow in here, right here, means approaches. Okay, so as x approaches negative infinity, f of x approaches what value? So f of x being the y, right? So as x goes to negative infinity, what is y doing? So we're describing what happens at the end. Same thing for the other. The next line, as x approaches positive infinity, f of x then approaches, then the answer will be either positive or negative infinity. So if we look at this example, we have the fact that our lead coefficient is -1, right? This -1 is coming from here. Lead coefficient is -1. So that means that this falls to the right. Our degree is 3. The 3 comes from the largest exponent that is there. And this is odd, which means our ends are going in opposite directions. Right? They start and stop in opposite directions. So as we first go to graph this, we can see that this definitely falls to the right. Because it's negative, it falls to the right. And because it's odd, we then have, if we're going down on the right, we have to go up on the left. What does that mean? Well, that means as x approaches negative infinity, now we're looking as x gets really, really small, goes to negative infinity, what's happening to our function? That pink line, it's going up to positive infinity. As x goes to the right to positive infinity, what's happening to this picture? It's going down, and it's going down towards negative infinity. And this is our description for our end behavior, and will be the notation every single time we describe what is happening on the end behavior. And it is based on 2 things, your lead coefficient and the degree of your polynomial. Okay, so let's look at a couple of practice problems. And we're going to do these 3 things. State our lead coefficient, determine the degree of the polynomial, and then finally, what are the end behaviors. So as we had before, our lead coefficient in this case is a positive 1, right? So if it's a lead coefficient that is positive, this is going to, I'll write it in here for today, rise to the right, right? That's going to increase. So on the right, it's going to go up. Then we have to state the degree of our polynomial. The degree of this polynomial is 3. This means it is odd, so the behavior is in opposite directions. If we already know we're going up to the right, we have to go down to the left. So finally, we fill in our end behavior as x goes to negative infinity. Where is the pink going? It's going down to negative infinity. As x goes to positive infinity on the right, we see that our picture is going up to positive infinity. And we've described that entire end behavior. In number 2, we have a lead coefficient this time of negative 5. Since it is negative, this means that it falls to the right. And what does that look like? That means on the right-hand side, this is going down to infinity. The degree of our polynomial is equal to 5. Right? There's our number. There's our highest exponent. It is 5, which makes it odd. So we have opposite behaviors. Down on the right means we're going to go up on the left. So as x goes to negative infinity, which is here on the left, this is actually going to positive infinity. As this goes to positive infinity on the right, it is going down to negative infinity. Number 3. Our lead coefficient this time is negative 2. And because it's negative, this is going to fall on the right. It's going to go down. And then our degree is 4, right? Which is an even number, which means we have to have end behaviors in the same direction. Right? So if it's even, if it's going down on the right, it needs to go down on the left. Even functions have same behavior on both sides. So finally, to fill in what our behaviors are, as x goes to negative infinity on the left, our function is actually also going down to negative infinity. As x approaches positive infinity on the right, our function is going down to negative infinity on both sides. And number 4, our lead coefficient, another plus 1, so it's positive. So this is going to rise on the right. And our degree is 8, which makes it even. So we're going in the same direction. So if we went up on the right, we're going to go up on the left. And finally, as we go to negative infinity on the left, look where the pink line is going. It is going up to positive infinity. And as we go to positive infinity on the right, we can see that that function, our y value, is going also to positive infinity. And last but not least, we have one more. And this one, we have a lead coefficient of 4, which is positive. So therefore, we are going to rise on the right. It's positive. We're going to go up on the right. The positive slope increases. Our degree value is 3. And this is odd. So we're going to go in opposite direction. So if it goes up on the right, we need to go down on the left. So describe to finish off the description. As we go to negative infinity, look where the pink curve is going. It is going down to negative infinity. As we go out to positive infinity for x on the right, we're going up to positive infinity for the y. So those were all the conclusions that you should have come up with for your assignment as you went through the graphs. And now we can conclude and go through our homework.